Good morning. Today I'm going to be going over motion graphs notes with you. I'm only going to be covering the distance time graph since that's what we've covered so far. I'll go ahead and post a video up of the position time and speed time graphs as soon as we go over that in class. So you know that motion graphs are picture representations of data and your analysis of that data. People are to look at these graphs and be able to tell right away the different variables that you had in your experiment and get a pretty rough outline of your results without having to kind of flip through a bunch of pages of data or look at tables and try to determine what the numbers mean. You should know that on the x-axis you have your independent variable, on the y-axis you have your dependent variable. 99% of the time in physics, on the x-axis you'll find the time. Not always, so you'll have to look at your variables in each experiment, but a majority of the time on the x-axis you will find that it is time that we're working with in physics. Okay, there's different types of motion graphs. You have a distance time graph, which we'll be looking at today. You have position time graph, and then you have a speed time graph. Distance and position time graphs often get confused together or with each other, but they're not the same thing. They're very similar, but they're not the same. We'll be looking at distance time graphs today, so it's this first example here. You can see that you have your two variables, so time and then distance. We use this in times graph to show the distance traveled over a particular amount of time, and since we're looking at those two variables, distance and time, we're able to calculate the speed of an object at any given moment during its motion. Okay, so if I'm going to be plotting data for a distance time graph, I need to make sure that one, I have a title, which I didn't put here, and two, I label my axes. So along the y, I'd have the distance. You can see that I measured it in meters, and then the time was measured in seconds. Once I have my axes labeled, I want to make sure that I put my scales on each of the axes. Now, a lot of people just put the numbers directly the way that they come here, so they would put 0, 5, 10, 20, 40, 45, 50. That's not correct. You can see here that they're not increasing by the same amount every second that passes, and that's what we're going to be looking at, what's happening, but you need to make sure when you put it on your scale that they are increasing in increments that make sense. So in this case, you could go by fives, you could go by ones if you had enough space, you could go by twos, you could go by whatever you want to make sure that you represent all the data that's in your table, but you need to go in an order that makes sense. Along with the same thing for the time. Time is usually easy because time is increasing by the same amount every time. So that one's pretty easy. 1, 2, 3, 4, 5, 6. You can do that. Try to take up as much space on each axis as you can. Don't try to fit it all in this little section right here because you have all this empty space for your graph. So try to spread it out as much as you can here, and then you can go ahead and actually plot the data points. I didn't plot them for you, but you can see that if you look at your table information and once you graph it, that you're not increasing by the same distance every time. So from 0 to 1 seconds, this person or object moved a total of 5 meters. From 1 to 2 seconds, again, it increased its distance that it moved by another 5 meters. But then there was a change. From 2 to 3 seconds, it went from the 10 meter mark, or from 10 meters, all the way to 20 meters. So it doubled the amount of distance that it covered in the same amount of time. So its speed was increasing here at this point. And again, from 3 to 4 seconds, it doubled again. So it went from 20 all the way to 40 meters. So it traveled a total of 20 meters here in this 1 second time period. And then you can see that you have a decrease in the amount of distance covered per second. So you can see that it was going at a constant speed, it started to speed up, and then it went back to going at a constant speed of 5 meters per second. Since again, you know the time and the distance, you can solve for your speed. Speed is always distance divided by time. Here are just some generic graphs. So we'll be looking again at the distance time graphs. So if you look at A, if something is moving at a steady speed, it means that we can expect the same increase in distance in a given amount of time. So here would be like the first 2 seconds of the previous graph that we just looked at. They were increasing their distance by the same amount every time. So every second that they were moving, they were increasing their distance by 5 meters. Eventually that started to change. But if you were to see a graph that has this straight horizontal diagonal line pointing up, that means that they're going at a constant speed. They're increasing their distance by the same amount every time. So B For a distance time graph, if you see a horizontal straight line, that means that the object is not moving and it's stationary. If I were to plot data here, let's say at this point it just stayed at this line right here, you can see for 1, 2, 3, 4, 5, 6, 7, however much time passes, it's staying at the 10-meter mark or whatever it is. So whenever you see a horizontal straight line for a distance time graph, know that the object is not moving, it's stationary. This one doesn't really apply to a distance time graph, so I should have removed it. That was my accident. But we'll continue on for D. So D, whenever you see a curving up straight line or curving up line going this way in a distance time graph, it is going to be showing that the speed is increasing. So you can see as time is moving on, the amount of distance that they're covering in that time is starting to increase. So the greater the distance you cover in a smaller amount of time or a particular amount of time, the faster you're going. Whenever you see a curved down line like this for a distance time graph, it means that the object is slowing down. So you can see that as time is increasing, the amount of distance covered every second is decreasing. So that's it for distance time graphs. Stay tuned for position and speed time graphs.